Hello students, welcome to YourPedia platform. My name is Arun Pathania and today in this video we are going to discuss another question that was asked in last year's HPCL interviews for civil engineering branch. So let us just read the question and try and solve it. So the question was why do we vibrate concrete? Now this is such a basic question, I think we should know the answer to this. Let me just tell you the right words in which you can answer. I think we vibrate the concrete in order to compact it. This should be the shortest answer that we can give. So we need to compact the concrete, therefore we vibrate it. Now why do we need to compact the concrete? So when we pour the concrete either manually or using a chute, what happens is that in successive batches that we pour the concrete, some air gets entrapped between that, some air pockets get formed. Air takes some space and the aggregates, they are now away from one another and it's not a very close packing. Okay, so the density of the whole mass is comparatively lesser and the arrangement is not homogeneous. So we compact it, we vibrate it, so that what happens is that all this entrapped air can be removed and the aggregates can be packed into a closer arrangement and we can have a higher density mass, we can have a homogeneous mass. That's what we are doing. As you can see from the picture, from here the aggregates are far away from one another. They have cement water paste in between them and they have air pockets also between them which are separating them. But after compaction, after vibration, what happens is that they get compacted into some closer arrangement which is beneficial and which is desirable. Now let me tell you what are the advantages of compacting the concrete. Why are we compacting the concrete? The benefits of vibrating and compacting the concrete, the first or the biggest advantage is basically the removal of entrapped air. When the entrapped air gets removed in form of air bubbles, it comes over to the surface and it escapes into the environment. When it gets removed, our concrete mass becomes homogeneous, it becomes more denser, and when it becomes more denser, it will have better strength, it will have better structural integrity, and it will be more durable also. And the another thing is the aggregates get closely packed. They come together, they get closely packed. Now the biggest advantage of close packing is basically it's effective. It is more effective against dynamic loading. So whenever dynamic loading or vibrations will come on our structure, concrete structure, it will be able to resist it in a better way if it had been vibrated. Therefore, nowadays the IS code specifies that, or the building code specifies that we have to vibrate the concrete every time we are using it for building, especially because vibrations and this impact loading, dynamic loading is going to come no matter what, it's going to come through earthquakes or through other things. So we need to compact the concrete, we need to vibrate the concrete. Now it is mandatory. We can't construct a building without vibrating or compacting the concrete. Another thing is it also decreases the porosity. When the aggregates will come closer, the pore size will reduce. Obviously the porosity will reduce. So what happens with the reduction in porosity? Now the environmental factors will have less effect on the concrete. It will absorb lesser chemicals and stuff. So therefore what happens is the concrete becomes more durable. Now it is better to resist the weathering agencies, it's better in resisting these weathering agencies, and its durability has increased. Okay, so compacting concrete is like compacting soil only. So in sandy soil also we apply vibroflotation. We vibrate the sandy soil. What happens is key air escapes from the voids and the grains, they arrange themselves in a closer packing. Now this sand is better in resisting dynamic loading. Its density has also increased. So it's a better, it has better engineering properties now. Its strength has increased, shear strength has increased. Similarly, same happens in case of concrete also. Now the question arises, how do we vibrate concrete? Like what are the various ways in which we vibrate the concrete? So let me tell you the different types of concrete vibrators that we have. The very first are internal or needle vibrators. This you must have seen these vibrators in the field only. These are very common, very economical, and most popular. So as you can see in the picture, this person is basically vibrating this patch of concrete, and it is placing the needle inside the concrete, and it is vibrating it from the within only. So these are comparatively cheaper, but we have to keep some things in mind. Firstly, we have to hold this vibrator as much as vertical as possible. Moreover, we can't vibrate at the same spot, at the same location for more than 10 to 15 seconds. Otherwise, what will happen, that the cement paste will get segregated, and the aggregates will now be different, and the water cement paste now will be like it will separate out, and that is not desirable. We don't want that. So what we do is we select a location, we place our needle vibrator inside it, and we vibrate for about 10 seconds. Then we remove the vibrator and we vibrate the next location. So location should be chosen in a uniform patterned way so that the compaction is uniform. Otherwise, you can't choose the location haphazardly, like you are vibrating here, then you are vibrating there, you are vibrating there. It will not be good, and the compaction will not be uniform. So you have to be very patterned regarding choosing the location of the location where the vibration will be done. The second thing is basically your foam work vibrators. Now these are vibrators which are attached to the foam work itself. These are basically used with metal foams more commonly, and what is that, these are basically used with precast concrete. So normal concrete, we normally go with needle vibrators or surface vibrators, but for precast concrete, foam work vibrators are more economical, and they are more commonly used for that kind of concrete. Okay, so last but not the least is basically your surface vibrators. These are used when the thickness of the member is not that much in which concrete is being poured. So you can't use needle vibrators effectively over there. So what you do is you use a surface vibrator. These are also used for CC pavements. What they do is they vibrate also, and they provide a smooth finish also. So we get two benefits from here. So that's what we have in case of vibrators. Now you know why do we vibrate, in order to compact, and why do we compact, because it has certain benefits which are listed over here. And how do we vibrate, what are the various methods in which we can vibrate. So we can use these different type of vibrators depending upon the type of concrete or depending upon the conditions that we have available with us. So that's what it is. Okay, so that's it from my side. I wish you all the best for your future endeavors. Thank you very much.